Everyone, welcome to the ITLS Academy. Today we are going to perform an experiment that is called a SDS page. Sodium dudosyl sulfate polyacrylate gel electrophoresis. SDS is a stand for sodium dodecyl sulfate and pages stand for a polyacrylate gel electrophoresis. Simply, this SDS page is used to determine the charged molecules, mainly the protein and the nucleic acid. And this SDS page are widely used in different industries like your biochemistry, forensic genetics, and molecular biology. And it is based on a principle that the charged molecules, we separate the molecules on the basis of their charge, or you can say that we separate the protein when it undergo a electric field. Okay. So in this experiment, what we have to do, we use a liquid or semi-solid matrix in which negatively charged molecules are moved from anode to cathode when the electric field are applied. Okay, and this flow of the molecules are totally depend upon the size of the pore or size of the protein. Okay, if the size of the protein is larger, it moves slowly, and the size of the protein are smaller, it moves fast. That means that if we get a that near, then it means that it is a large protein. Now, for this experiment, we use some chemicals for the formation of the gel. First type of gel that we prepare is a separating or a resolving gel, and the second type of gel that we produce that we prepare is a resolving gel. Now, for the second is the stacking gel. So, for the preparation of both type of the gel, we required some chemical like your bisacrylate, acrylate, SDS, APS, that is called ammonium persulfate, tris HCl, and chemid. Okay, so this bisacrylate are used to introduce the cross-linking between the polyacrylate, and this acrylate are used to determine the pore size of the gel. Okay, suppose if the pore size of the gel are large, then then the larger proteins travel, and if the gel size are small, if the pore size is small, then smaller protein will travel. The concentration of this acrylate is high, then it means that the pore size is small and only the small protein can move through pores. And if the concentration of this acrylate is high, then it means that low, then it means that the pore size is high and the larger molecules can travel. Then we use this tris HCl for to separate the protein, and SDS is used to denature the protein and again create a cross link and again bind it in a uniform form. Then this APS is used as a catalyst, and it is helped to produce a acrylamide. And also this APS is used as an oxidizing agent so that the acrylate and the bisacrylate can be polymerized. And this stamate is used as chemical initiator, and it can trigger the polymerization of the bisacrylate and acrylamide. Basically, these are the chemicals that we are going to use, and we are preparing separating gel 12% and um, stacking gel 4%. So first of all, we have to prepare some chemical, like I'm going to prepare a SDS. SDS we are preparing 10%. So for this, what we have to do, we dissolve 10 we dissolve 5 grams of this SDS into 25 ml of distilled water. Now I am going to weigh 25 ml of distilled water. This is 25 ml of distilled water. Now I am going to weigh 5 gram of this SDS. The first chemical that we are going to prepare is what? Is SDS. First of all, we have to prepare all the chemicals. Then we see what is the procedure. So for 10% of SDS in 25 ml, we required 5 gram of SDS and it will be dissolved into a 25 ml of the distilled water. Prepare this as a stock because it can be used in separating gel, in stacking gel, and also in a buffer solution. So approximately it is 3 gram. Now I am going to dissolve this 3 gram into first 25%. Then again I am going to weigh 5 gram. Sorry, 2 gram. And one more thing, you have to prepare the chemical freshly. So you have to prepare it on the time of the experiment. It is, again, I am going to weigh SDS 2 gram. It's 2 gram. Now, 10% of SDS, first you have to dissolve into a 25 ml of distilled water. Then you have to again add a 25 ml of distilled water when it is completely dissolved. See, now it is completely dissolved. Now I am going to add more 25 ml of distilled water into it. Now 10% of SDS is ready. Now after that, I am going to prepare a 10% of APS. So this APS are, again it is prepared for 0.5 ml. Now this APS that we are going to prepare is our second chemical and it is weighed for 5 ml because we need it very little amount, so that we are going to prepare this ammonium persulfate only 5 ml. So for this we required a micro pipette for the weighing of 5 ml. This is 1 ml. This is 2 ml. 3 ml. 4 ml. 5 ml. Now after that, you have to weigh a 0.5 gram of APS. See, this APS is very important because we all know that it helps in a preparation of the polymerization. So it this APS and the TEMET will be added into a gel during the time of the pouring. Otherwise, the reaction is start. So you have to weigh only 0.5 gram. 0.6. So you have to remove some amount of APS. You have to weigh again. Because the weight of the APS is very crucial. 0.3, 0.4, 0.5. Now this is 10% of APS. So we have prepared two chemical. One is your 10% of the SDS and one is your 10% of your APS. Now we are going to prepare another chemical that is your 30% of acrylamide, and this acrylamide contains two components. One is your bisacrylamide and another one is your acrylamide. So we are going to prepare 100 ml. So for 100 ml we required acrylamide 20 sorry, if you are preparing it for 100 ml, then you require 29.2 gram of acrylamide and 0.8 gram of this acrylamide. Now we are going to prepare it only for a 5 ml because again we require it very small amount. Now the next chemical that we are going to prepare is the 30% of acrylamide. For the preparation of the 38% of acrylamide, we need two chemical. One is your bisacrylamide and another is your acrylamide. Okay. So if you are preparing 30% of acrylamide for 100 ml, you require 29.2 gram of acrylamide and 0.8 gram of bisacrylamide. Here we are going to prepare it only for a 5 ml. Okay. So again, with the help of the micropipette, I am going to take 5 ml. 1, 2, 3, 4, and 5. So for the 5 ml of this 30% of acrylamide, we required acrylamide 1.46 gram and this acrylamide 0.04 gram. So first of all, I am going to take a acrylamide. This is your acrylamide and the amount this acrylamide is what 1.46 gram. One point 111, 1.44, and it is 1.46. Now dissolve this 1.46 of acrylamide into a 5 ml of distilled water. Now the another chemical that we required here is a bisacrylamide. And the amount of bisacrylamide that we required is only 0.04 gram. 0.04. So 0.80. So you have to remove it. Again, I'm going to take a weight because it is not correct. 0.03 and a little amount of required. Now it is 0.04. Now you have to add it into a 30% of. So our third chemical is also ready. It is 30% of acrylamide. Now we have to prepare a two solution of tris HCl, one for a stacking gel and another for a separating gel. Okay, for a separating gel, we require tris HCl 1.5 molar, and then we have to maintain its pH 8.8. For a gel, we require the tris HCl of 0.5 mole, and its pH should be a 6.8. So first of all, I am going to prepare for a separating gel. For separating gel, we require 2.36 gram of tris HCl and it will be dissolved into a 10 ml of distilled water. Now with the help of this measuring cylinder, I am going to take a weight, measure the volume, and I am going to prepare a 1.5 molar of tris HCl. So we required 0.36 gram of tris HCl. How we calculate it? We calculate it with the formula weight is equal to molarity multiplied by molecular weight multiplied by volume taken divided by 1000. That's how we get a weight of the HCl. Here it weighs at 1.43 gram. We have to require a 2.36 gram. 2.10, 2.11. See, the amount of this tris HCl and the pH of the tris HCl is very important. Now it is 2.36. Now dissolve this 2.36 into a 10 ml of distilled water. Now first maintain its pH with the help of the pH meter. Then after that, I am going to prepare another tris HCl of 0.5 molar. So we required pH 0.8. Sorry, 8.8, not 0.8. Here the pH is around 8 point something. So we have to add a NOH into it so that its pH reaches 8.8. You have to wait when it is stable, then the pH will be count. So before taking the pH, one thing you have to do, that is the calibration of the pH meter. It is very important. So how we calibrate the pH meter, the video related to this are already uploaded in our account. You can go and check. So its pH is reaches 6.7. So you have to add more. You have to require 8.8 pH. 7.5. pH is 7.2. Reaches only 7.5. Add more. Now it has reaches 7.7. More NOH will be added for maintaining its pH. still more NaOH will be added because it reaches only 8.12. Now we have prepared 1.5 molar of this HCl whose pH is 8.8, and the second is 0.5 molar of this HCl whose pH is 6.8. Now after that we have to prepare two gels separately. One is your separating and one is your stacking gel. Okay. First, we prepare a separating gel because it will be filled first inside the your casted tray in which we do this SDS page electrophoresis. But when you are preparing this separating gel, you have to note one thing, that is Kemet and your APS will be added during the time of the pouring. Okay, so we are not going to add it. First of all, we are going to prepare that separating gel 12%. For this, we required a water 3.2 ml. First of all, we required a water 3.2 ml. Distilled water will be required. 1 ml, 2 ml, 3 ml. Then, with the help of this, we change it 100 microliter. Sorry, 200 microliter with 3.2 ml. Then after that, we are going to add a 30% of acrylamide, 4 ml. This is your 30% of acrylamide. It will be added 4 ml. 1, 2, 3, and last one is your 4. Then after that, we are going to add our SDS. Will be added 100 microliter only. Your 10% SDS, it will be added only 100 microliter. Now we are not going to add this APS and timid. So this is our separating gel, 12% is ready, in which the timid and the APS are not added. It will be added during the pouring. Now the second is your stacking gel. In a stacking gel, the amount of water is 5.8 ml. So first of all, you have to change the 5.8 ml. 1, 2, 3, 4, 5. Now add 100 microliter more. It becomes 5.8 ml. Then after that, we are going to add 1.34 1.34 ml of APS. Sorry, acrylamide. 30% of acrylamide. This is 1 ml. And now we have to add 34 microliter more. Then after that, we are going to add 2.6 ml of 0.5 molar of Tris HCl. So first of all, you have to add 2000 microliter. Sorry, 2000, yeah, 2000 microliter. One, two. Now, more 600 of Tris HCl will be added. And the last 100 microliter of SDS. Again, APS and TEMET will be added during the time of pouring. In separating gel, I forget to add the Swiss SCL, so I'm going to add one, two, now our two gel are ready. One is your stacking gel and one is your separating gel. Separating gel will be added first. Then after that, we are going to add a stacking gel. Now see, now I'm going to demonstrate you about the apparatus. Then after that, we are going to add this APS and the TEMET into the solution. Now, after preparing all the solution for the gel, that is your separating gel and a stacking gel, we have to pour these gel into the caster frame. Okay, now before pouring this gel into the caster frame, I am going to tell you about the instrument that we are going to use in SDS. Okay, so simply, first of all, you can see that this is your plates. Okay, we use two plates like this. Okay, and in between them we are going to fill the gel, both type of the gel. First we fill a separating gel, and then after that we are going to fill the stacking gel. Okay, so in between these plates we are using this spacer. Spacer is used like this. We have to put this here, and these two spacer will be put here, and with the help of this silicone grease we fix this spacer into the plate, and then again we have to put the plate into it. Okay, so you have to do this thing very carefully. You have to wear a glove because the silicone grease is what they are toxic in nature. And one more thing, when you are stucking this plate with the help of this spacer, you have to do that like this. Here the space will not be there. Okay, so we already prepared this plate. You can see that this is our spacer, this is our first plate, and this is our second plate, and it is joined together with the help of these silicone grease, and this separator is called a casting frame. Okay, in which we are cast the gel. Okay, now you after this, the second instrument, this is your main tank. In main tank, what we are going to do, we fill our running buffer and put the casting frame into it. And this is your power pack, in which the cathode and anodes are there, and this is for a volt, and this will be connect with the casting frame. And when you are pouring this gel into the this plate, you have to clean this plate with the help of the ethanol, so that any dust and dirt will not be there. Now after that, what we have to do, we have to pour the gel into the in between these plate. Okay, so I already told you how we I already told you that how we prepare these two gel. We add all the chemical into the gel. Like first of all, if we are going to prepare a separating gel, so we need a acrylonitrile, trisacil, APS, SDS, and timid and distilled water. Okay, so APS and timid will be added when we are going to pour this gel into the frame, because when we are adding timid and APS, the immediately reaction are started and polymerization are occurred. So for this reason, when we are going to pour this gel into the in between these plate, we are going to pour it. Okay, so here I already poured this separating gel into the in between these plates, and then after 30 minutes when it is solidified, I poured the another gel, that is your stacking gel. Same here, you have to avoid the APS and timid before adding it. This will be added during the pouring time. Then again it will take a 30 minutes for the solidification, and here you can see that the wells are formed. Okay, see, these wells are formed with the help of these comb. What we have to do, we put this comb inside the in between these gel, and when it is solidified, we remove this comb, and then a wells are formed. Okay, now in well, what we are going to do, we add our sample. Okay, so this is all about the gels and apparator. Now after that, we need two type of the buffer. One is your running buffer. These running buffer go inside the tank, and another is your sample buffer or a loading buffer. Okay, so first of all, I am going to tell you the composition of these running buffer. Again, these running buffer are prepared according to your capacity of the tank. If the tank are large, then you have to prepare more amount of this running buffer, and if your tank is smaller, then at that time, if and that time you have to prepare a smaller amount of your running buffer. So the composition of the running buffer is, it contains 25 millimolar of tris HCl, 200 millimolar of glycine, and 0.1% weight by volume of SDS. So these are what? These are the composition of the running buffer. And if we are preparing it for 800 ml, then it will contain around 30.3 gram of tris HCl, 144.4 gram of 200 millimolar of glycine, and 10 gram of 0.1% of SDS. So these are what? These are the composition of the running buffer. Then after that, I'm going to tell you the composition of the sample buffer. Sample buffer contain a 10% of SDS, 10 millimolar of beta mercaptoethanol, 20% of volume by volume of glycerol, and 0.2 molar of tris HCl whose pH is 6.8, and 0.05% weight by volume of bromophenol blue dye. Now, what we have to do, we mix all these chemical into the beaker, and then when we are going to load these loading buffer into the well, at that time we are going to add our sample into it. Okay, so here what we add, a mixture of the proteins. Then what we have to do, we have to put it into the hot water, put it into the water bath at 100 degrees Celsius for a 10 minutes. Then after that, we are going to pour this inside the well. Okay, so let's start the experiment. I am going to pour the sample into the well. Then after that, we put this caster frame inside the tank, and then after that, we fill the running buffer into it, and uh, start our power pack, and then bags are formed, and it will take time. So let's start the pouring. Now with the help of these micropipette, I am going to pour this sample around 1 ml into the well. Not 1 ml, we have to pour it around only 500 microliter, 0.5 ml. Again, you have to avoid the bubbles. If you get a bubbles, then please change the tip. Now when you are pouring this into a well, you have to take a care that the sample should be poured inside the well only. Now after pouring the sample into the well, we have to put this caster frame inside the tank. Like this. Now after that, we have to pour the running buffer into it. Mix it properly before pouring the running buffer into it. See, the whole plate are submerged inside the running buffer. Then we have to connect it connected with the power pack. Then switch off the power pack, set it around 150 volt, and then start the experiment. Okay, so it take around 1 to 2 hours to get a result. We get a band. Okay, so we all know that if we get a band near the well, then it means that the molecular sorry then it means that the size of the protein is larger. And if we get a band far away from the well, then it means that these proteins are smaller in size. Okay, so with the help of the Comasi stain, we stain it and see the band inside the UV light. So this is all about the SDS page, how we prepare reagents, how we prepare a gel, like your separating gel, stacking gel, how we prepare these two type of the buffer, how we prepare the running buffer, how we prepare the this loading buffer, or you can say that the sample buffer, how we pour it, and how many it take around 30 minutes for the solidification of the one gel, and then again we pour the another gel, then again it take us 30 minutes for the solidification. So everything we performed in this experiment, I already told you. So this is all about the SDS. I hope you will understand. But if you have any query related to this topic, you can ask me in a comment box, or for a further detail, you can follow the ITLS Academy on Instagram, Facebook, Twitter, YouTube, WhatsApp, and LinkedIn, and subscribe our channel ITLS Academy on YouTube and get our app from a Google Play. Visit our website www.itlsacademy.com. Thank you for watching. Please like, share, and subscribe our channel.